Quick review on solving systems of equations. What is the solution to this system of equations? Remember, the solution to a system of equations is where the two lines intersect, or where the two lines are going to cross. So let's see our two lines. We've got to convert these into slope-intercept form before we graph them. So for the first line, this line right here, I'm going to convert that to slope-intercept form by first getting rid of this x that's being added to my term with my y. I want to get y by itself. So first I want to get rid of anything that's being added to my term that has the y. So this 1x has to go. I'll add negative 1x to each side to get rid of that. Those two cancel out, and on my left side I'm just left with 4y. On my right side I'm left with negative 8 plus 1x, or plus negative 1x. Next I'm going to have to get rid of the 4 that's being multiplied to my y, and to do that I need to divide everything by 4. Now that I have everything divided by 4, the 4 will cancel out with this 4, so I'll be left with y, and over here negative 8 over 4 reduces to negative 2, and I carry down my negative 1/4 x. And I'd make sure that I don't forget my plus sign right there. This means that for this line, my slope is negative 1/4 and my y-intercept is negative 2. I plot my y-intercept right there on my y-axis at negative 2, and then I can go down 1 and over 4 to plot my next point. I can also make a point that's up 1 and left 4. That's going to fall on the same line as my line is going right now. And if I were to look at a point over here and go down 1 and over 4 back to my original point, I would see that I was following the exact same pattern as I used to plot that point. Next equation, got to get rid of this 5x that's being added to my 4y. I'm going to add negative 5x to each side. This will give me 4y equals 8 plus negative 5x. I need to get rid of the 4 that's being multiplied to my y, so I'm going to divide every term by 4. This will give me y equals positive 2 plus negative 5 over 4x. I'm going to plot my first point on my y-intercept, which is positive 2. And I'm going to plot my second point down 5 and over 4. I could also plot it up 5 and left 4. That would fall on the same line as my other points. Those lines intersect at the point 4, negative 3, right there. That's where they cross. Therefore, the solution to this system is 4, negative 3. Try this one on your own, and there's some graph paper on the back of your guided notes if you need it. What is the solution to this system of equations? The solution is negative 2, negative 1, C. What is the solution to this system of equations? Answer C. More review. Vertical and horizontal lines. Vocab. Quick vocab, you can write this in that first empty box that says more review. Vertical lines are the ones that go straight up and down like this. Horizontal lines are the ones that are flat and go side to side, and sloped lines are the ones that are slanted. So we're going to just get this vocabulary down and address any issues and get this to be automatic. So a couple ways to think about why these are called vertical, or how to remember that these are vertical and these are horizontal lines. The word horizontal is derived from this word horizon. The sun sets over the horizon. Look at the beautiful sunset. There's the sun, and it's over this horizon. And what we'll notice is that a horizon is just a horizontal line. Vertical lines, we can think of vertical jumps. When we are measuring vertical jumps, that's a fitness measurement that people use to see how strong their legs are. So a vertical jump tells you a lot about the power that is in your legs, and that's a common measurement that coaches use to measure their athletes' fitness. Here's a video about just a 1-minute clip of this guy talking about vertical jumps. So just keep on thinking about that vocabulary. Why is this called a vertical jump? Oops.
The vertical jump is very similar to the broad jump, and it's going to test how strong you are with that lower body and those big muscles. Now, some people naturally just jump high, given a natural God-given ability to jump. But I think what it also tests for a lot of coaches and scouts is how often you're in the weight room squatting and doing all those important lower bodies, because you can really elevate your vertical jump if you work hard at it. So what they do is they measure you with a flat-footed reach. Okay? They're not going to let you cheat with your feet. You get your hand up as high as it can go, and at that point they're going to mark it. Now, the differential between that mark and whatever flag they hit after they jump is your vertical jump. Now, remember, no rocker steps, no cheating. They really make you just lock in there, bend, and elevate. And it's kind of fun to watch some of these guys get up. And I always love the D-backs and the wideouts because they sky. They average about 48 inches. Now, there was a guy at the '09 Combine, first-round pick.
All right, so hopefully that'll help you remember vertical, like have something to associate the word vertical with that upward or downward movement. So anyway, here, quick recap. Vertical lines are this straight up and down. Horizontal lines are straight side to side like horizon. And then sloped lines are lines that are slanted like this. So here we have vertical and horizontal lines. Let's look at those equations for those kind of lines. So we have a line y equals 2x, a line y equals 2, and a line x equals 2. Which of these is vertical, which of these is horizontal, and which of these is sloped? We're going to investigate that right now. Horizontal lines have a slope of 0. And our example of a horizontal line is y equals 2. Now basically what this equation is saying is that the y coordinate is 2. Y is 2. The y coordinate of any point on the line is always 2. So we need to make a line that has a y coordinate that is always 2. And here we can see that. If I plot my first point can be on the y-intercept, which is at 2, 0, 2. I can plot another point at some other point that has a y coordinate of 2. Here I did -4, 2. Oh, oops, I'm sorry, -3, 2. Okay. And sorry, I had to fix that point. And the last one at +3, 2. I could plot those wherever I wanted to as long as the y coordinate was always 2. We can see right there, every single point on this line, the y coordinate, y, is 2. Now notice here, there is no x in this equation. If there is no x, what is the x coordinate to a point on this line? Can use my good old friend Harry Potter to help me out with this one. No offense, but I don't care. It doesn't matter what point the x coordinate is. The x coordinate can be any number as long as the y coordinate is always 2. There's no x here, so I don't care what x is. X can be any number. It's just important that y is 2. Vertical lines. Slope is undefined. X equals 2. The x coordinate of any point is always 2. X is 2. The x coordinate is always 2. So I need a line that shows that the x coordinate will always be 2. That is this line right here, a vertical line that goes through my x-axis at 2. Now, just like with our horizontal line where it didn't matter what our x coordinate was, it doesn't matter here what our y coordinate is, because this equation does not have a y in it. It just says that x is 2. So all I need to make sure is that x is 2. Last, sloped line. This is what we mostly deal with. And an example of this is y equals 2x. Here it says the y coordinate of any point on this line is always 2 times the point's x coordinate. So here I can be able to see that right here. Here's a line, my line y equals 2x. Notice it has a y-intercept of 0. I could write +0 at the end of this. And from 0 I can go up to over 1. That is my slope. So here, if my point at -2, -4, I notice that I can take my x-coordinate, -2, I can multiply it by 2, and I will get my y-coordinate, which is -4. Another point on this line of an infinite amount of points. Also, there's an infinite amount of points between here that all lie on this line. I just put the whole number of points to make it easier. -1, -2. -1, the x-coordinate, multiplied by 2 is equal to the y-coordinate. 0, the x-coordinate, multiplied by 2 is equal to 0, which is my y-coordinate. 1 multiplied by 2 is equal to 2, which is my y-coordinate. Coordinate of 2, if I multiply that x-coordinate 2 by 2, I get my y-coordinate of 4. Every point on this line follows that exact same pattern. All right, for the equation below, state whether the line will be horizontal, vertical, or sloped. This line is going to have an x-coordinate that is always -1, and to do that, to have an x-coordinate that's always -1, that's going to require me to have a vertical line. For the equation below, state whether the line will be horizontal, vertical, or sloped. Obviously here we have a sloped line. Y always needs to be -1 times whatever the x-coordinate is, so as the x-coordinate changes, the y-coordinate is going to change as well. All right, match the equation with the appropriate graph. This is going to be the y-coordinate is always -2 is what this equation is saying. On choice C, I have a y-coordinate that is always -2 no matter where my points are on this line. So that is my answer. Match the equation with the appropriate graph. Y equals -1x plus 2. And this is going to mean that the y-coordinate is always -1 times the x-coordinate plus 2. Here, with choice B, I have -1 times the x-coordinate, which is 0, plus 2, and that equals my y-coordinate of 2. Another point is -2, 4. -2, my x-coordinate, times -1 plus 2 is my y-coordinate, 4. And I can do this with every single point on the line. My x-coordinate times -1 plus 2 is always my y-coordinate. -1 times -4 is 4, plus 2 is my y-coordinate of 6. Here, I have to get x by itself first, simple one-step equation, and then I know that's going to be a vertical line through 4 on the x-axis, choice A. All right, go to Khan Academy, practice graphing systems of equations, complete all mastery challenges, and begin your homework.